This is a flow chart from your textbook, and some people like flow charts. This helps you organize your thinking. If that's you, by all means use it. If you find this confusing and you want to figure it out a different way, then just completely ignore the flow chart. I'm not going to make anybody use a flow chart. But let's use this to just kind of give us an overview of naming. So there are three classes of compounds that we're learning to name and write formulas for. Ionic compounds, we recognize these because they have a metal in them. A metal and a nonmetal. We're looking at the first element. If it's a metal, you don't have to think anymore. It's an ionic compound. All compounds that start with a metal are ionic in this class. There are also a small number of compounds that do not start with a metal that are ionic, and those are ones that start with NH4, the ammonium ion. Naming ionic compounds, your book talks about whether the metal forms one or two or more than one type of ion. I say, well, ask yourself, is it in groups 1A, 2A, 3A, zinc, or silver? If it's one of those, no Roman numeral. We know the charge from the periodic table. If it's not one of these, we're going to use a Roman numeral in parentheses after the element's name. The example here, FeCl3. Fe is not in groups 1A, 2A, 3A, zinc or silver. It needs a Roman numeral. Because it could be 2 plus or 3 plus, and if we don't write that in the name, we don't know. Not even the most experienced chemist is going to be able to tell you. Iron chloride, what's the formula? Well, is it iron 2 chloride or iron 3 chloride? So this would be iron 3 chloride. And it's very important, those Roman numerals are capital I's. Mastering chemistry cares about this. If you put in an L, a lowercase l, or the number 1, it might look the same, but Mastering Chemistry is going to count it wrong. I've heard from several students that had that problem. Something like Cai2, calcium is in group 2A. We know from that it's got a 2 plus charge. We don't need a Roman numeral. So this is just calcium iodide. The nonmetals, if you have 2 nonmetals, that's a molecular compound. And here we're going to use the Greek prefixes, mono, di, tri, tetra, etc. to tell how many of each element. You put a prefix with the name of the first element and then a little space and a prefix with the name of the second element, and you change the ending to "ide," and there you go. If we have only one of the first element, we usually drop the mono. And then the acids that we just talked about. There's binary acids, hydrogen and another metal. We use the prefix hydro. Take that element name, change the ending to "ic." HCl becomes hydrochloric acid. Oxyacids contain oxygen. So we look at the ions in them and find the name. Does it end in "ite"? You change the ending to "us" and add the word acid. So H2SO3. SO3 is sulfite. So this becomes sulfurous acid. On sulfur and phosphorus, sulfur has this syllable, and phosphorus has that syllable in the element name. Those kind of come and go when we name ions and acids and compounds. I will not try to trick you with that on an exam. I'll just correct it. So you might think, well, that would be sulfus acid. I wouldn't mark that wrong, but it's actually sulfurous. The UR comes back. Why? I don't know. I don't have a good reason for that. If it ends in "ate," we change the ending to "ic." So H3PO4. PO4 is phosphate. And so it would be completely understandable if you said, well, phosphoric acid. Well, the comes back. Phosphoric acid. Again, I don't think that's a big deal. This example in the textbook is trying to show you how would you go about using that flow chart to name specific things, like here, CO. So you'd recognize it's got 2 nonmetals, so you would pick the molecular path on the flow chart, and then you'd apply the prefixes, you end up with carbon monoxide.